The extreme value theorem states that if a function f is defined and continuous on a closed interval a, b, then f has a global maximum and a global minimum on a, b, and it's either going to be at an endpoint or at a critical point. So a couple things to note here: we must have a closed interval. And f must be defined and continuous on that interval. Okay, so if we're not thinking about the extreme value theorem, so we're not thinking about an interval, look at this first graph. This first graph has a local min at this critical point and a local max at this critical point. But what about the global min and max? If we look at that, this graph continues down towards infinity, which goes past the local min, so there is no global or absolute min. And for the maximum, the graph continues up towards infinity, past the local max here. So again, there is no global max. We look at graph number 2. There's a local min at this critical point. There's a local max at this critical point. And then there is another local min at this critical point. So when we're looking just at a graph at local mins and maxes, we're just looking at dips or rises, like mountains in the graph. Okay, but what about global mins and maxes? Well, the graph continues up to infinity in both directions past the local max, so there is no global max for this graph. However, this point here that was our local min is the absolute minimum of the graph. So this is the global min. At the same point as this local min. So it's possible in general that we could have no global min or max, but we could have local mins and maxes. It's possible that we could have one of those, but not the other. It's possible that we could have a global max and a global min if we're just looking at the whole graph. But what the extreme value theorem is saying, it's saying if we restrict our graph to a certain closed interval, then what's going to happen is we're definitely going to have a global minimum and a global maximum if we restrict it to that interval. If it's not restricted to the interval, like examples 1 and 2, it's possible that we might not have one of those or both of those global maximum and minimums. So just so you can see what that looks like, let's consider an interval from A at this x value on graph 3 to B at this x value. So we're just going to look at this part of the graph between A and B. Now on that part of the graph, I see a couple of critical points. And I also see the endpoints. Since we're looking at a closed interval, the endpoints could end up as the maximum or minimum points. Okay? So now let's compare these points and see where our global maximum and our global minimum is. So our absolute highest point on the graph is this critical point. when we're only looking at the graph between A and B. Of course, the graph does go higher here, but this is not in the interval. So the extreme value theorem says ignore what happens outside the interval. And this critical point is our global maximum for the graph on this interval. Now let's look for the absolute lowest point. So this was a critical point, but there is a point lower, and it's the value attained at the end point B. So that value is our global min. So you can see that when we restrict the graph to a closed interval, if the graph is defined in continuous, then we will definitely have a maximum and minimum point. Let's look at one more example. Graph number 4, looking at the closed interval from A to B, means we're looking at this portion of the graph. Let's go in and look at endpoints and critical points of this graph. There's an endpoint. Here are some critical points. So we do have quite a few local mins and maxes on this interval. We care about the global minimum and maximum. The absolute highest point is attained at this endpoint. And the absolute lowest point is attained at the other endpoint. So this is a graph where if we had been looking at the whole graph, this graph would have had no global max and no global min because the arrows, the ends of the graph, point to infinity in either direction. However, since we're looking at the closed interval by the extreme value theorem, these endpoints can be the global min and max.